I'm Andy Hostetler, and this is David Peters, Jerry Bartra, Deputy Director of Offender Services for the state of Iowa. And today we're going to tell you about a project that we've done, which is predicting recidivism on reentry in the state of Iowa using propensity methods. Our agenda for the day, I'm going to start and tell you a little bit about the project and Iowa's correction system. Jerry's going to speak about reentry in the state of Iowa and the Iowa reentry program. Then we'll tell you something about our population, the persons that we did the study on, so that you can compare our population to your population, other groups, how these techniques can be used, might apply to any population that you want to deal with in evaluation research. Then Dave's going to talk about propensity methods, and this is the technical heavy part of the program. Hopefully useful to you, and I think it will be. I was looking at the program, and there are several persons at the conference right now presenting findings where propensity methods have been implemented. So what we hope to, if nothing else, accomplish is to give kind of a general technical understanding of how these methods are used, what these statistical corrections are for, and how they might change the findings that you come up with. And even if you are not a person that goes out and does this in evaluation research, it will make you a more informed consumer, I hope, of what these techniques are, how they can perhaps even flip around findings. To do this, we're going to illustrate our findings in this state. Ours is not an evaluation of a particular program. It's an evaluation of reentry across the state in a given year. So, but there's no reason that these techniques can't be used for any singular program as well. Then we're going to conclude, if time allows, with some implications. This part of the implications comes from some qualitative follow-up research that we did talking to parole and probation officers across the state. So part of our experiment today is we're going to use these little clickers that we've handed out, and this is the first time that we've tried the clicker exercise, so bear with us if all of our technology doesn't go smoothly. What we were just interested in who is attending. So if you would look at these categories and see if you fit, and there's another category at the end, tell us what you do for a living. Well, I don't know what we can take from this, but it appears that we are administrators and others, right? So we'll see how useful these techniques are as we proceed. So a little bit of background on our project is our goals were to understand individual and community factors predicting recidivism across the state. And to that end, we have lots of demographic and risk propensities that we examine. We also, it's a pretty inclusive model. Both our model predicting treatment and our model predicting outcome has, I would say, it's just about everything you could think of is thrown into this model. So when you see the results, don't think we have left the control variables out. There are many, many, many control variables. We had treatment provisions and quality of the treatments that offenders receive. We had the driving distance to the Department of Corrections, to main parole probation offices. We had driving distances to various social services offered across the state. We had residential community location and census variables, most of them measuring kind of wealthy, underprivileged workforce kinds of variables about communities where offenders were residing upon release. Our project was funded by the National Institute of Justice, and the grant had a couple of purposes, one of which was to bring a new researcher to the study of crime, and Dave is normally a rural sociologist who specializes in community stuff, so that was his role. Another was to partner with a state agency, Department of Corrections in our case. And a third was to take something that social scientists were doing to disseminate and apply to a very practical question. And our question is probably the oldest question in corrections. What predicts who recidivates, and what is the effect of treatment on recidivism, and is the effect of treatment an artifact or a reality? And that's what the propensity methods are for. So our plan of work is to predict the probability of recidivism at 2 years. The model, as I said, is very inclusive, contains everything that's in an offender's file. In addition, we did a follow-up component of the study where we went out into the field, I guess you could say. We visited all 8 community corrections districts in the state, talked to persons of various rank, only 24 interviews, but we had a pretty focused set of questions by this point that we wanted to ask. And what we were mainly doing this for was to see how confident parole and probation officers were about data quality, how much they are the persons that enter the data, so how confident they are about data quality, how they apply risk assessment in their daily lives, where they go if they want to truly assess an offender or a client's risk, because I was very good about data, so there's lots and lots of data, and they have lots and lots of options when it comes to assessing, personally, what the risk of an individual client that they're working with. So we wanted to know, yes, you have all of this information, but how are you using it? And in addition, we wanted to get some things that we could not model. There are lots of things about clients that you can't model. You can't get into a statistical program, even if it's almost infeasible to imagine collecting data on it. And there are, of course, things about community corrections districts that we could not model. For example, some community corrections districts really emphasize cognitive restructuring. Others don't have the resources, perhaps, to do that. Some have special things about their populations, maybe heavier rural populations. Some have particular programs that they think are very, very successful just because the quality of the program, right? Where our quality, all we have for that is a numeric score, but they could say this person is particularly talented at implementing a program, and that, of course, wouldn't be in our model. So for us as social scientists, it's error, and these are the kinds of, we wanted to learn, where our error is occurring. Finally, our goal is to disseminate results with a set of research tools, and that's what we're going to talk about a lot today. And in addition, to come up with some suggested best practices, things to improve. And the qualitative interviews were very useful here, right? No one can tell you how to improve things other than the people that really have to do the work. I'm going to turn it over to Jerry, and he's going to tell you a little bit about reentry in the state.
We have 8 judicial districts. The judicial districts all have its separate board of directors who does select the district director. Funding for the correctional districts is through the Department of Corrections. So we have a funding relationship as well as a policy relationship, as well as let's make sure that when we have offenders in prison, they move to CBC, that we're doing the same kind of stuff. We have 9 correctional facilities, and they range anywhere from reception center to maximum custody to minimum custody, scattered in all different areas of the state. This morning we had 8,114 offenders in prison, which is 14.4% over capacity. 631 of those people were female, so we have a high percentage of women in our system. An important component of our process, of our system, is community-based corrections, and there were 30,590 folks being supervised by CBC this morning. 28,700 were in field services. Of those, there were 21,666 on probation. In our business, we think that probation is a part of reentry, because if we can do a good job of people that are sentenced to probation and keep them in the community, that helps manage the cost of corrections. We also have a better opportunity of integrating people into our community as law-abiding citizens. So we place a lot of efforts on that probation population, which we aren't going to be talking about today, but it's a huge part of our system and a huge part of our response. We have 3,600 offenders currently on parole supervision. 569 on special sentence, and special sentence is kind of a parole sentence for people that have been convicted of a sex offense. Laws passed in 2005 said if you're convicted of a sex offense, you will automatically have a period of time mandatory supervision in the community. So it's kind of like a parole status. We have 1,503 folks currently on pretrial release with supervision. We also have 1,887 offenders currently in residential facilities. Residential facilities are managed by community-based corrections. They do receive offenders from the institutions on work release status, and of those 1,887, 463 on work release status. 128 are OWI continuum. We divert some people with OWI offenses from prison to the community to serve their sentence. And 577 of the folks that are currently in residential facilities are on probation. So we use residential facilities as a kind of an intermediate sanction for offenders that are on probation. Just another couple bits of history to kind of get to where I'm going to get to on the slide today. In 2000, we were fortunate in Iowa to develop a database that began to capture data about offenders from the point that they're on supervision until they discharge. We rolled that out to the CBCs in 2000. In 2002, we entered prison data. So we have a database that tracks offenders from the moment they're placed on supervision until they discharge. That's the wealth of data that Andy and David were able to get at to do some of their research. In 2004, we committed ourselves, both in CBC and the institutions, to evidence-based practices, and risk, needs, and responsivity principles were put in place. We think it's important, too, that we have those same kind of skill in the institutions. So we kind of saw CBC as a lead in this. We think it's important enough, if we're going to impact recidivism and community safety, that the same kind of principles are practiced in our institutions. In 2007, with a cohort that was beginning to be studied in this study, we added intake staff at the Iowa Medical and Classification Center, our reception center, to increase our ability to do assessments at the front end. And we developed a reentry case management process where we use the same case plan in the institutions and in community base. So those are some things that kind of were leading up to the point that we're at now when the research began. In 2007, we changed the mission of the Department of Corrections to read. We advanced successful offender reentry to protect the public, staff, and offenders from victimization. Prior to this point, we were heavy duty into let's protect the community. The offender success piece is the piece that we added in 2007. To do that, we think it's important to create partnerships and utilize evidence-based practices to prepare offenders to be pro-social members of our communities without correctional supervision. So in that mission is embedded this notion that reentry also applies to our probation population. It's not just people that are returning to the community from prison. That same year, we developed what's called the Iowa Reentry Model. The Iowa Reentry Model includes a defined process and procedures to guide effective reentry from sentencing to discharge, taking into consideration differences in resources in different parts of the state. It's not only differences in resources, but there's differences in population from rural to urban. And how can we make the reentry model apply to both? The Iowa Reentry Model has its goal reducing future criminality, victimization, and involvement in the criminal justice system. The Iowa Reentry Model includes assessing offender risk with actuarial risk and needs tools. Risk reduction is our primary focus. It's important to match the level of supervision and services to the risk level of the offender. Applying cognitive behavioral interventions based on risks, needs, and matched to individual characteristics. Utilizing a seamless case management plan and process. Identifying a range of incentives and sanctions for offenders, implementing continuous quality improvement, measuring performance and outcomes, developing a range of supportive systems so that offenders have those kind of supports in place when they do return to the community, building partnerships in and outside of corrections, and one of those partnerships we think is most important is developing a partnership with the offenders that we're serving. Ensuring effective communication amongst all partners in the process, and staff is our most important asset in making this model work, so hiring, training, and retaining the right staff. So that was the stage that was set at the time that Dave and Andy began to do this research.
With every study, it's important to understand the population of interest. And I'm going to just give you the descriptive statistics of the pro population that we studied. One reason for that is, of course, so you can say, could I generalize the findings to the types of people that I have to deal with in whatever evaluation we want to do. And I think most of what I'm going to do is kind of make the case that when it comes to the important things, this population is probably very like the populations that you deal with. So we chose for the study where the grant was focused on reentry. And by reentry, the National Institute of Justice had kind of a different definition. They're not including probationers in their definition. When their grants they were giving for reentry were for persons who were coming out of prison. So we defined our study population with that in mind, to keep the granting agency happy. And one of the things we did is we cut out all of the OWI offenders, and the reason is they were going to special institutions serving short sentences, probably not dealing with the same kinds of reentry issues as the the subjects of greatest interest. Then we took all offenders who were paroled from prisons in 2010, or special sentence, which is a very, very small number, so we thought we'll just count the special sentences as parole. Our study does not contain probationers. We used only offenders that had a valid Iowa address, and the reason for that is we were interested in this community level stuff and what influence it played. So if we didn't know where they lived, we did do some kind of creative things. If it was homeless, we would place them in the center of the city where they were homeless. But that was easy to do. But generally speaking, it's offenders that we could tell where they were. And those, of course, who had got out of the state one way or another didn't appear. Those who maybe ICE had picked up, those that were in an institution do not appear. So for that reason, we're pretty confident that our recidivism rate is accurate, right? It is not the disappearances we have removed. It's persons who are not institutionalized. At the end, we had 1,270 parolees in the state. And probably, just like your state, in fact, similar maps can be found for lots of states in the nation, and they almost all look this way. The parole population is a heavily urban population, and you can see that we've mapped out the metro areas in Iowa in bold, and then we have the rate of parole returns right here, and those in the center of the city is where most of the parolees are living. That's how the U.S. population is distributed as well, right? So no real surprise there. But very important to keep in mind as we talk about rural-urban differences, access to services, drive times, is that most offenders are very concentrated in larger cities. Probably our demographics, most of the demographics reflect what is generally true of prison and parole populations. The average age is 38. They're mostly males, 85%. Minorities are overrepresented in the state, and of course, it being Iowa, it probably is not nearly the percent as it is in some states, but it's vastly overrepresented in Iowa, right? 25.7 to 11.3. Most of our parolees were Iowa-born. That was especially true in rural areas. They had one dependent person on average. Most had a GED level education, and unfortunately, few are employed full-time or part-time 1 year after being released. That too is generally true of parolees across the nation, so we don't take credit for that. They have a moderate LSI risk, 29.81, and of course, if you know your LSI scores, and I know a lot of you do, the LSI experts would say that that's a high risk, but for a prison population, that's a moderate score. That's one of the things about the LSI is with a prison population, it's skewed up to the top, which means there's not a great deal of variation. They have a lot of previous convictions. This is a coming out of prison population, 7.7 on average. They served about 2 years on their last sentence. Most are drug offenders. 1/5 are violent offenders, a few more in the micro areas. Few are sex offenders. There are more sex offenders in rural areas. The treatment that we are interested in is any completion of a high priority program. And Iowa prioritizes its treatments. A lot of the prioritization is done in classification. You could be treated in community corrections. You could be treated in prison. But if you complete it, our main interest was, does it make a difference if people complete a priority program, something that the state has said this is what you need? And there's a lot of reasons for doing that if you're interested in general treatment effects. And one of the reasons that we learned soon off is that community corrections personnel vastly overestimated the number of people who were completing priority programs. And the reason that this happens is almost everyone completes something, right? And and that's what people would say is everyone gets treatment, right? That if you're coming out of prison, of course you have been treated. And that's true, but have you completed a high priority treatment and a program with some intensity? That's a different question, and of course the numbers become much more conservative there. So Iowa assigns priorities, and what we said is, yes sir?
So these are treatment programs in prison?
They could be in prison or in community corrections in the first year out. So you could have got it in a halfway house as well. So we said, at some point you were given a priority before you were, 1 year after release, had you completed a treatment for that priority, either inside or outside. And 1 or 2, because sometimes you can't get your highest priority just because you know how it works, right? You're not in an institution at the time that they're offering the class, so they say, well, this is your priority 1 need. We just can't offer it. You're only here for 2 years. The timing doesn't work out, so we're going to go ahead and service you for your priority 2. So we counted 1 or 2. And you can see that if you do that, about 35% complete at least 1 treatment. About 11% complete more than 1, and 3 completions is fairly rare. The primary priorities that are completed are for alcohol and drugs. Some criminal attitudes and companions are also prominent priorities. So that's good. Those are the priorities that are commonly occurring, can be effectively treated, and those are the ones that people are receiving services for. Our recidivism measure, so you understand, it's always important to understand what someone means when they say recidivism. Our recidivism measure is perhaps conservative. We've run it all kinds of different ways with all kinds of different recidivism measures, so we're aware of all the definitional problems with what are you going to count as recidivism. But we decided for today's presentation we're going to count any new arrest as recidivism within 2 years. About 39% recidivate with this definition within 2 years of release, and you can see that about 29.8% return to prison. Those numbers are fairly consistent no matter where you are, metro, micro, or urban. For time to failure, this is capped at 731 days, 2 years out, so if you take you realize all those people who made it are coded at the maximum. The average time to failure was 558 days, 18.6 months. Rural offenders make it a little bit longer than do urban ones. Sexual offenders, violent offenders also show higher failure rates, and I think that too is probably true across the United States. Now I'm going to hand it over to David, and he's going to tell you about the heavy part of the presentation.
Right, so as Andy said, I'm going to be talking about how you actually implement these propensity methods. So I'm going to talk a little bit about what are the disadvantages of trying to assess, or some of the challenges of trying to assess treatment's effect on some outcome when you're not able to randomize people into experimental groups, into treatment groups or non-treatment groups. And then I'm going to review with you a little bit of how we applied those methods to the Iowa data. And as Andy mentioned, I'm a rural sociologist, and so I study rural communities, and in Iowa, that's a priority of the university. But my other hat that I wear is I also am the methods, the quantitative methods expert in the department. So the other role I have in this project is helping out with the quantitative analysis of the data. So the first, we're going to use clickers again. So the first question is, thinking about where you work, are you allowed to do randomized experiments? And so are you allowed to take a group of, let's say, parolees or individuals in prison, and all would be eligible? Are you able to randomly select, put those to give a treatment to half of those individuals and the other half not? Look at the results. It looks like almost never, which is very common, of course. I mean, there's legal issues. Obviously, you can't deny someone a treatment if they're eligible. But that sort of reemphasizes one of the issues of evaluating treatment effects in a corrections or in a criminal justice system. So in the statistical literature, randomized experiments are the gold standard in evaluating treatment. So you see this primarily in biomedical research, where they're able to do experimental trials and randomly assign a group of participants. Half will get the experimental drug, the other half will get some placebo. And that really is the best way to look at, to evaluate treatment, because it removes through the randomization by randomly assigning people into a treatment group and a placebo or a no treatment group. You're removing any kind of potential bias there would be in those individuals. But of course, in corrections research, we're not typically able to do that, or it's very rare that we're able to do that. Particularly from an Iowa Department of Corrections, if an inmate or an offender is eligible and treatment's available, in general, we're required to allow them to participate in that treatment. So we really can't do experimental designs. What we have to do is we have to use statistical methods to sort of create an experimental design. We have to use statistical trickery, if it were, to try to replicate what a randomized experiment would look like. And we do that using statistical means. And so we call those types of studies observational studies, where we have data where people are not assigned randomly to treatment, but we use statistical techniques to control for that bias. And we'll talk a little bit about what this bias means. So one of the problems would be, so let's work through an example of what do we mean by bias in non-random assignment of treatment. So in Iowa, this is an issue for us. We typically have lower risk offenders than other parts of the country. And we also know from our analysis that low risk offenders are both more likely to complete treatment and they're more likely to fail. Now, if we simply ran our analysis looking at the effect of treatment on recidivism without controlling for the low risk of the offenders, we know that low risk is associated with both treatment and our outcome variable. And that low risk is a source of bias. And so really, when you're evaluating the effect of treatment, if treatment shows it really has a strong effect at reducing recidivism, it may not be the treatment itself. It may simply be that those are lower risk offenders to begin with, that only low risk offenders complete a treatment. And of course, if they're a low risk offender, even if they did not complete a treatment in the first place, they were still less likely to fail in the beginning. And so what these statistical models try to do is try to control for that confounding effect. Now here we're just talking about one potential confounder, this low risk, but there can be many potential confounders. And so what we want to do is look at the true effect of treatment on an outcome that removes all this other noise or all these other potential factors that could influence that relationship. So we call that pseudo-isolation. We want to isolate the effect of treatment on an outcome and hold constant everything else that might affect that relationship. And we call those quasi-experimental analyses or quasi-experimental methods. And we implement those. One popular way to implement those are with what we call propensity score methods. So what are propensity scores? Let's see. Basic steps of the propensity score. So the basic steps are threefold. First, we need to estimate a propensity score, and I'll explain in a minute what a propensity score actually is. Second, we need to apply a method. We need to take that propensity score and statistically incorporate it into our analysis. And then the third, we simply run our common evaluation method, whatever that is. And so there's three key steps, and we're going to talk about the first two in this session, and the third would be whatever statistical model or whatever evaluation model you first intended to use, you would just go ahead and do that as you initially planned. So what's a propensity score? A propensity score is a probability, so it's a probabilistic, since it's a statistical technique, it deals in probabilities. It's the conditional probability that an offender actually completed a treatment that we can predict that. So given their initial risk factors, given their demographics, given everything else we know about them, what's their probability that they actually finished a treatment? And then we compare that probability to whether they actually did or did not complete a treatment. So it's our best guess, it's our statistical best guess rather than simply guessing the mean. It's our best guess whether an offender will actually finish a treatment or complete a treatment knowing that background. And this propensity score is really the workhorse for these propensity methods. It's this propensity score that we use to really estimate the amount of bias there may be in between this treatment and our recidivism outcome. And it's the propensity score that allows us to create these quasi-experimental designs. So it's the mechanism, it's the means by which we're able to replicate what might happen or what would likely happen if we were to randomly assign people into treated and non-treated groups. It's our statistical best guess. So the best guess would be the mean. So if we're saying 30% of offenders get a treatment, our initial best guess would be the mean, but we can use statistical methods to improve on that, saying if we take so for each individual offender, if we take their demographics, their risk level, their prior offense, their number of months they've been in prison, previous convictions, we can take all that information and we can create a better guess than simply guessing the mean. Because some will be higher, some might be more likely to complete, some might be less likely. It would depend on the individual mix. So we use a statistical model, which we'll go over in a minute, to get our I say a guess, it's our statistical best guess on how we do that for each individual. And so just conceptually, the way these propensity scores work is that you first calculate this propensity score for all offenders. So what we did, we had about 1,300 parolees in our sample or in our study. We calculated a propensity or a probability that offender actually received a treatment or completed a treatment. We did that for all 1,300 parolees. And then we grouped parolees based on similar propensity scores. So we looked at all offenders that, say, had an 80% chance or more of completing a treatment, and we took that small group and we split them into those that actually were treated or were not treated. And then we went to the next group. So instead of the 80 to 100% treatment, we looked at next the 60 to 80 group. We did the same thing. We split those into treated and untreated, and we do that. And so what the propensity score, what that's effectively doing is saying, if you have the same probability of getting a treatment, there's no difference between those two groups in terms of their background, their demographics. And we have a table here that demonstrates that for the Iowa data. And so when we do these first two bullets, when we take everyone with the same propensity score and we split them into treated and untreated, statistically speaking, what the statisticians have argued is that now they are essentially, you can mimic a random assignment, because if you randomize people into treated and untreated groups, there should be no systematic differences between those groups. And here, we know there is, but we've used this propensity score to sort of model what that might have looked like using statistical means. And now we can compute the mean differences between the treated and untreated groups on some outcome within each propensity score. So for example, in our Iowa study, and this is on slide 34 if you're interested, in our Iowa sample we took, these are for all those 1,300 parolees in Iowa, and if you look at those so we looked at the mean difference between those that completed a treatment for their priority 1 or 2 need and those that did not complete a treatment for their priority 1 or 2 need. And without doing any propensity adjustment, these are the mean differences. We can see, so wherever you see the flags, that means it's a statistically significant difference. So we see first off that males are much more likely to complete a treatment in Iowa. We see those born in Iowa are more likely to complete a treatment. We see that those that are paroled from prison are much less likely to complete a treatment. So you see all of these differences. So without adjusting so everything that's flagged, these are these confounding effects. So treatment isn't assigned randomly. Not everyone has an equal chance of completing a treatment. Men are more likely, women are less likely. People born in Iowa-born parolees are more likely. Non-Iowa-born parolees are less likely to finish a treatment. Those that come out of a prison are very less likely to complete a treatment. Those coming out of halfway houses are much more likely to complete a treatment. So we have these systematic differences between our groups that is going to obscure that relationship between treatment and recidivism that we would not have with random assignment in an experimental method. But if we apply these propensity methods, you see these mean differences essentially zero out. So we've taken this initial bias in who actually completes a treatment, and we've done this through the propensity score, and we've removed it through those methods. And that allows us to go ahead and analyze our data without any of these potential confounders. So the first step is how to actually compute or calculate a propensity score itself. The most common method is to use a logistic regression where you have a binary outcome. In this case, it would be those that completed or did not complete a treatment. It's the most common method. It's the most straightforward. It gives you a nice probability. It outputs a probability. If you're interested in the number of treatments, and so let's say you're not particularly interested in just completing a number of priority 1 or 2 treatment, you just want to know how many treatments they did complete overall, you can use a Poisson regression that can model the probability of completing a number rather than just yes, no, completed a treatment. You can actually get a probability of the degree of how many treatments they completed. But that's not very common in the criminal justice literature. All right, so in our Iowa example, you have your outcome variable is, again, whether they completed the treatment or not. And then for the predictors, you would include essentially everything you think is relevant. And so typically when you do statistical analysis, you want the model to be what we call parsimonious. You want the model to have as few variables as you need. You don't want to throw in all sorts of variables. But in propensity methods, the goal is to maximize, to explain as much variation as possible. And so the way these things are done in the literature and the research is that all potential confounders are thrown into the model. So you might, in our model, we had 100 plus predictors. So the goal isn't to isolate the effect of one particular one. We want to try to predict that. And so these are a vector of variables. These are all the potential demographics you might have: age, race, ethnicity, income, parents' income, socioeconomic status, you name it. A whole list of variables measuring the type of offense, how many previous offenses they have, how long they served in prison, and in any other data you have. And then, of course, all of their risk scores. In our case, we use the LSIR risk measures, the individual risk measures to do this. And so you want to throw in everything that you think is relevant to try to get this probability, try to get a most accurate propensity score as you can. And I should say, as Andy mentioned, at the end of the slideshow, or at the end, we have a website, a URL for our web address. We have a project website that has the SAS code and a sample data set, so you can see how you would actually do this. And so you can see what our propensity model looks like. You can run it in SAS, and it all works. And we as well have a short technical paper that explains this more in depth. And so that's actually posted now, and so you can access that at any time. So that's how you create the propensity score. You would run a logistic regression and save that predicted probability, and that is your propensity score. But once that's done, you have to evaluate that propensity score and to see if it's a good one. So the question that you asked here in the front row is, how good is that? So what's the quality of that propensity score? And there's 2 ways we evaluate that. One is whether that propensity score balances and if there's overlap. Because with any statistical model, you can throw in variables and you'll get a result, but you also have to evaluate whether it's a creation of the model or if actually it's a useful statistic to use in your analysis. And we evaluate propensity scores on balance and overlap. And balance is essentially that table I showed you on slide 34 is, does it control for group differences? So a good propensity score should essentially zero out all of those differences between a treated and untreated group. And the typical way to do that is to use a multivariate GLM or a MANOVA with using the propensity score as a covariate. And so an example of balance would be that table I showed. So not using the propensity score at all, we found these differences. Here are the risk differences between parolees that completed a treatment and did not complete a treatment. So that's sort of the baseline. And then if the propensity score is a good propensity score, if we did our job and correctly estimated that propensity score, then all of those differences should net out to 0. So if you have a propensity score and you see a difference when there's no adjustment, and you run the propensity score and you apply that, and you still see a significant difference, that means that the propensity score hasn't done its job. So remember, the goal of the propensity score is to balance out or remove this bias that we find. And in the Iowa sample, it's biased towards Iowa-born, to men, and to those coming out of halfway houses. And so we want to control for those differences. So in this example, our propensity score that we ran did that. It zeroed almost all of these out. These are zero. These are statistically zero. And so there's no difference between the treated and untreated group along these variables. The balance assumption is the first criterion that you have to meet. Is that does it control for those differences that you observed without any adjustment? The second important quality of a propensity score is that you have to have enough cases, you have to have enough treated and untreated parolees or offenders within a certain range of propensity scores. So there should be what we call overlap. So this is 2 offenders, treated and untreated. They have the same propensity score. And so what you want to do is you want to find a group of offenders or a matched pair of an offender that completed a treatment and one that did not complete a treatment but that had the same propensity to complete a treatment. So out here in the tails you could have an offender, for example, that did not complete a treatment or that did complete a treatment, but you're not going to find an equivalent one that did not complete a treatment in this one. So you have to have enough matching cases. And that's the overlap assumption. And you do that essentially by plots or by scatter plots and linking the lines together to look at that overlap. So in the Iowa example, we had so first our propensity score in the Iowa data did a very good job at balancing. That wasn't an issue. But this is the overlap for the Iowa data on the propensity score. You see that for people with propensity scores at a 20% probability of completing treatment, we have a lot of cases of those that completed a treatment and a lot of cases for those that did not complete. So we can find a lot of matched pairs. The problem gets to be at the tail of the distribution. So if you have, for individuals that were had a 90% odds or a 90% chance of completing a treatment, we have a number that completed a treatment, but we have no parolees with a propensity score of 90% that did not complete a treatment. So that's a problem, that we have a number of offenders that have a high propensity to complete treatment, but we don't have a non-treated to compare them to. And so you want to make sure that there's these, the ideal situation would be to have these 2 lines, these 2 distributions be on top of each other. But in this case, we have a problem that we have more treated, but hardly any untreated. And the whole idea of overlap is you want to make sure that there's enough treated and untreated at every point on this axis of the graph. So that's the other way you evaluate propensity scores. There has to be enough overlap. So once you've estimated the propensity score and then evaluated it in terms of overlap and balance, the next step is then to use that propensity score to take that propensity score and use a particular method to incorporate that into a statistical analysis. And there are 4 main propensity methods. They all use the propensity score, but they all use them in different ways. Each method has advantages and disadvantages. And the results of the analysis will differ based on which method you use. So one of the problems of using propensity score methods is that different methods may give you different results. But that's, in some ways, a third way to evaluate the quality of the propensity score is that if your propensity score is estimated well, the results should be almost identical no matter which method you employ. Okay, so we're going to talk about those methods. The first method is to simply include that propensity score as a covariate in your statistical model. So you just add it as a covariate. It's very easy and straightforward to use. It's probably the most common. The other advantage is that it retains the original structure of the data. And that means that it doesn't weight the data. It doesn't minimize the number of cases you have. It maintains the same structure of the data in terms of number of cases and the recidivism rate and the percentage that actually completed a treatment. But the covariate method has a couple major disadvantages. The major disadvantage is that it can't be used in a lot of common statistical techniques that use least squares estimators because it violates some of the assumptions of the least squares model. And so one of the big critiques in the literature of using the covariate adjustment is that you violate some of these assumptions because the propensity score is correlated with the residuals. The error variances aren't constant across values of the propensity score, and it becomes nonlinear. And so that's a lot of technical details, but the main thing to keep in mind is that if you're using an ordinary least squares regression, we would advise that if you're going to use ordinary least squares regression to predict, to use treatment, completing of a treatment on an outcome, predicting an outcome using ordinary least squares regression, the covariate adjustment would not be recommended because it's going to violate some of those assumptions. Now, the homoscedasticity assumption is, OLS is pretty robust to violations of that, but just keep in mind that using the covariate adjustment does violate some of these assumptions that you might not, that the results of that outcome model are going to be less than ideal. Okay. The next common way to incorporate the propensity score is to create a weight. So let's say you have 100 offenders you're interested in. You can use a weight that will create, that will double count some of those offenders in the model, in your data, to try to balance out those differences. And so if you have 100 original cases and you apply these propensity score weights, you might end up having 500 cases. And so what it does is it weights certain offenders more than once to try to balance it out. The advantage is that it doesn't violate any assumptions of any statistical model. So if you use the inverse weighting technique, you can use almost any kind of evaluation model you choose. The main disadvantages are, well, you could read through these disadvantages, but the main two are that, one, it distorts the original structure of the data. And so in our example, we had 1,300 offenders. When we did the weighting, we had 2,500 offenders. So we've increased the size, but we've increased them artificially just simply through double counting offenders through the weighting process. And the second is that because it weights individual cases more than once, what these inverse weights tend to do is count extreme offenders 30 times, 25 times. So Andy, in our model, we looked at the propensity weights, and some of these very outlier offenders that had a unique combination of risk scores and demographics, they were being weighted 25, 30 times in the data. And so that's a problem from our perspective, in that you're weighting these unique cases that has the potential to give you very, very odd results. To calculate the weight, it's very straightforward. This is a simple mathematical calculation that you take whether they actually completed a treatment or not, divided by their propensity score, and then you take 1 minus each of those and add those together. And this creates their weight. So it's very easy to implement in most statistical packages, and then you would just weight your regression analysis with that weighting variable. So it creates a unique weight for every offender. And we, in looking at the different kinds of weights to use, we think it's probably most important to use the weight that tries to generalize to a population, your population under study. That would be sort of the population weights rather than the treatment-only weights. And again, if you go to our website, the web address will have the code that kind of demonstrates how this actually works. We have the formula that actually calculates that weight, and you can look at the data set and see how that's done. So it's very straightforward to implement. So the good thing is that it balances the number of cases between treated and untreated groups. The main disadvantage is that it increases the sample size of the data pretty quickly, or very largely. For example, if you go to page 37, you see, so let's just look at the top, sort of everything that's, well, you can look at all of this, but so non-adjusting, if you look at the number of cases in the top line, oops, this has a, if you look at the top case, you see originally we had 1,270 cases. Using the covariate adjustment, we don't change the number of cases in our data. Using the weighting, we add over 1,000 cases to the data. That means we're double counting offenders multiple times in the data set. In terms of the rate of recidivism, this is the original data. The covariate adjustment doesn't change that. The inverse weighting increases it a little bit. And then you see for treatment completion, what we say that it balances is that we should have half and half. You should have 50% completed, 50% did not complete. And so one of the advantages of the inverse weighting is it balances the number of cases between the treated and non-treated groups. Now the third propensity method that we typically use in criminology and criminological research is the stratification method. Now unlike the previous methods that I've talked about, the stratification method divides your offenders into equally sized strata. And so typically you divide your sample into 4 or 5 groups. In this case, or the most common way to do that in the literature is to use quintiles. So take the different 20th, we take a fifth of each of the sample and divide them into five groups. That's what we did in our research, and that seems to be standard in the literature. Though there's no concrete rule on how many groups to have. In most published research, 4 or 5 are typically used, with 5 being the most common. And so each stratum represents the likelihood of being treated. So remember, we're stratifying based on the propensity score. So the higher the propensity score, the more likely it is for that offender to be treated, and the lower the propensity score, the least likely probability of that offender being treated. So for example, if we take the bottom 20th percentile and call that the first stratum, those are the bottom 20% of parolees that are least likely to be treated. And if we take the upper quintile, those 80th percentile or higher, so those whose propensity scores are in the 80th percentile or higher, those are in the 5th stratum, or the 5th quintile, and those are most likely to be treated. And typically what happens is that you analyze, so you'd run your analysis on each strata. And so you'd run your analysis on the least likely to be treated and the most likely to be treated. So what you want to find out is, does treatment have an effect on recidivism for those that were least likely to be treated, and does treatment have an effect on recidivism for those most likely to be treated? And you can compare the differences. And so what you should find is that treatment should work very well for the most likely to be treated, or that 5th quintile, and treatment should not matter for the 1st quintile, or the least likely to be treated. Some of the advantages are that you can see very clearly how treatment works differently across those most likely and least likely to be treated. And oftentimes what you find is you have a very strong treatment effect on those most likely to be treated, and you have a very weak treatment effect on those least likely to be treated. And that's typically what you would want to see. And that would confirm that your propensity model has correctly adjusted for differences in the propensity to get treatment in the first place. If you see the opposite results, that's typically an indication that something's wrong with your propensity score. Some of the disadvantages are mainly that we have, you cut the number of cases for analysis. So in most criminological research, we don't have very large sample sizes. And so let's say you have 100 people in a program that you want to evaluate. You're essentially dividing them up into groups of 20, 5 groups of 20. And most times you can't do very sophisticated statistical analysis with only 20 cases in a group. And so that's one of the disadvantages. To use the stratification method effectively, you typically have to have very large numbers of cases or large sample sizes. And the reason that the sample size issue matters is that when you have very small numbers of cases, those statistical parameters become very unreliable, become more biased, become less efficient, and we have less confidence in those parameter estimates. The other perhaps big disadvantage from a more pragmatic perspective since this is a conference on community corrections, is it's hard to really explain to non-technical audiences why you're running separate analysis on each of these strata. So the analysis is harder to present to non-technical audiences, and it's much more harder to interpret. So it's much more straightforward to only present one analysis and discuss one set of results, but with the stratification method, you have to interpret at least two strata, the bottom strata and the upper strata. And then even more complex is if you have to interpret the middle strata. So those that are in the third, for example, stratum, it's really hard to have a good idea how or what a third quintile really means in terms of probability to get treatment. It's sort of an average value, but the treatment effect is much more difficult to ascertain. So the main disadvantages, as I said before, is that it just has very low cell sizes that complicate statistical analysis, and actually presenting the results to non-technical audiences is very difficult and cumbersome because you have to present more than one kind of statistical analysis. The stratification method is very easy to implement. So unlike the case matching method, which is very complex, the stratification method is very easy and can be done by most researchers that have sort of an average level of skills. And to do the stratification method, you simply would sort all of your offenders or all your cases by the propensity score. Second, you would determine the number of strata that you want, either 4 or 5. If you want 4 strata, then you would take quarters, the bottom 25%, the next 25%, and so on until you get to the 4th strata, which would be 75 to 100%. Or if you want to do 5 groups, you would do 1/5 of each of those. So take 20%, the bottom 20%, and work your way up to the top 80 to 100%. And so you decide on those number of strata. That would give you your percentiles. So in the case of 5 groups, we'd want a 0 to 20%, a 20 to 40%, a 40 to 60%, a 60 to 80%, and then finally the 80 to 100% score. And what you would do is you would just find out what the propensity score value is at each of those upper percentiles. And then you would simply group them into those 5 groups, and then you would run your statistical model on each stratum and interpret those results. So it's very straightforward to do. Most computer programs have an automated function that allows you to divide a sample into any percentiles, thirds, quarters, fifths, and so on. So to summarize, I've talked a lot about different types of propensity methods, how to calculate a propensity score, how you use that propensity score in statistical analysis. We've discussed kind of the advantages and disadvantages of each method, but at the end we really want to summarize and kind of condense everything that we've talked about up to this point into a very concise set of recommendations. And the table that you see on the screen gives a nice summary of all of those different methods and highlights what we think are the advantages and disadvantages of each method. So looking at the screen or looking at the table, we can first talk about how each different propensity method changes the data that you're working with. So if we look at that first row, we see that the number of cases that the covariate adjustment, as we mentioned earlier, doesn't change the number of cases from what you originally have in the data. There's no difference. However, when we use the inverse weighting, we see that we effectively, we almost double the number of cases in our analysis. And so the inverse weighting overcounts the number of cases, and it does that to try to balance the treatment completion rates. And then the case matching and the strata method all reduce sample sizes. And so you see, depending on what propensity method you use, you're going to change the number of cases quite a bit. So weighting is going to really overcount or really increase this number of cases, and the matching and the quintiles are really going to reduce the number of cases substantially. And why this matters in statistical analysis is we have this issue of what we call excess power. And that means essentially the more cases you have, the more likely it is that you're going to see statistical coefficients be significant. So the more cases you have, the more likely it is you're going to detect differences, and you might get what we call statistically significant but trivial results. And so that's the only danger in using the weighting method, is that you double the number of cases, you're more likely to find significant parameter estimates, but those statistical significance values are going to be essentially trivial. They're going to be very trivial. In terms of the recidivism rates, we find that really different kinds of propensity methods really don't change the actual recidivism rate or the day or the time to recidivism. The only way, the covariate adjustment, the weighting, and the case matching, they're all essentially identical to the original data set. However, what we did find is that with the stratum method or the strata method, the recidivism rate was a little bit lower than the other ones, but there really wasn't much difference. Really wasn't much difference. In terms of treatment completion, we do see very substantial, very sizable differences. So again, as we mentioned earlier, the covariate adjustment really doesn't change the original structure of the data at all. It effectively mirrors it. But we do know, what we presented before, is that the inverse weighting and the case matching, what those two methods try to do is they try to balance out treatment completion so that you have equal numbers of treated and untreated cases. And you see that by looking at the percentages for inverse weighting and case matching. You see that inverse weighting, the treatment completion rate is 49%, and it's exactly 50% for case matching. Those two methods are the best at approximating a randomized experimental design, where the covariate adjustment essentially keeps the original treatment completion rate. Now, as I just mentioned in the previous slides when we talked about the strata method, remember that when we group offenders by their propensity to get treatment, by doing so, we're going to vastly change the treatment completion rate. So if you look at the first quintile, remember those are the group of offenders that are least likely to be treated, and we see that the treatment completion rate is less than 5%. By contrast, the fifth quintile are those parolees that are most likely to get treatment, and we see almost two-thirds of parolees in the fifth quintile actually received a treatment. And so one of the issues, or one of the problems with using the strata method, is that you have big differences in treatment completion rates across those. In terms of balance, we did talk about balance. Essentially, almost all of the propensity methods adequately balanced the covariates. We see that in the raw data form, we only had a balance. Only about 70% of the covariates were balanced. After making those adjustments, we see we're almost all at 100%, 95 to 100%. So all of the methods are essentially equal in balancing. So those are the more of the statistical or the data considerations when choosing a propensity method. And our recommendation, at least in terms of the data analysis, is to use either the covariate adjustment or the case matching method. The covariate adjustment really does minimal, it has a minimal change on the original data structure, which is advantageous. And then the case matching is preferable because it most closely approximates an experimental design. So our advice to anyone doing propensity methods is to run two analyses, one with the covariate adjustment that essentially corrects for treatment completion without a lot of distortion to the data, and the case matching that best approximates these randomized trials that we're talking about. Now, in terms of other considerations that people ought to consider when they're running a propensity method, in addition to the statistical and data adjustments, are one, how difficult it is to implement those techniques, and second, how effective is it? How effective can you present those results to your audiences? One of the first considerations is in terms of the statistical techniques you can use with each propensity adjustment. So the best ones are the inverse weighting and the case matching, in that you can use case matching and inverse weighting propensity methods on any kind of statistical technique. There's no limitations. Now the covariate adjustment, while it's very easy to implement, one of the problems is that it might violate some of the common assumptions of the least squares of the general linear model, in that the errors would be correlated. You don't have independent errors, and sometimes including the propensity term results in nonlinear parameters, and those are all violations of the least squares, of the family of least squares estimation techniques. And so it's oftentimes, you're cautioned in using typical regression or least squares regression analyses, you're cautioned not to use covariate adjustment because there's a potential to violate those assumptions. As I mentioned just previously, one of the big disadvantages of the strata method is that by dividing your sample into fifths, you really reduce the cell sizes or the number of cases in each of those strata, and that complicates statistical modeling. So you really can include many predictors in those models, and with low cell sizes, those parameter estimates become very unstable. In terms of important decisions that you have to make as a researcher or an analyst, we find that the covariate adjustment, the inverse weighting, and the strata methods are all really easy to implement. You only really need to make one crucial decision. For inverse weighting, you have to choose what kind of weight to use, a population weight or a sample weight. In the strata method, the only real decision you have to make is the number of strata, 4 strata, 5 strata, 6 strata, or so on. The case matching method, so related to the number of important modeling decisions you have to make is the technical expertise needed. And since you only need to make one or none non-important modeling decision, most individuals with a background in corrections research can easily do the analysis. So of course the covariate adjustment can be done by very novice users. It's not very complicated. The weighting and the strata method are all very simple. It's very common data adjustment. So for most individuals in the correction system with very minimal training, they should be able to run covariate adjustment, inverse weighting, and strata propensity methods and not need a lot of technical expertise. However, the case matching does require 4 important decisions. There are decisions that you really need to think clearly about in terms of whether you sample with replacement or not, whether you use random starts or go in the order of which the data fall, whether you need to specify caliper distances, and so on. So there's a number of important decisions you have to make in case matching, and to implement that in a statistical program requires a lot of expertise. And so while the case matching method best approximates an experimental design, which remember is that gold standard in treatment research, to do it properly using the case matching method does require a lot of thought and a lot of experience and background in running these models. And then lastly, since this is a community corrections research conference, we can talk all we want about the technical details and the statistical details on how you run these models, but at the end of the day, you do have to present this to the people in the correction system. You have to present your results to non-technical audiences, and they have to be readily understood. And some of the propensity methods do a better job than others at doing that. And so the covariate adjustment is very simple to present and very simple for non-technical audiences to understand, since you're simply including an additional variable in your model. Case matching is also very simple to understand in that you basically tell people you're presenting to that you took everyone that completed treatment and then you found a matching pair that did not complete treatment, and you simply say that you're replicating an experimental design. And so it's interesting, the tension in the case matching is that even though it takes the most technical experience to implement, once you've done your analysis, it's very simple and straightforward to present. The inverse weighting, even though it's pretty easy to do statistically, it does require a little bit of work in explaining why all of a sudden you've doubled the number of cases in your sample. And so if you talk with a community corrections group, and they know there's roughly 1,300 parolees in the state and you present your inverse weighting and you're presenting a number of 2,500, it's really going to raise an alarm with them that why are you double counting, or why did you double the number of parolees in the state? And so people get, non-technical audiences can get suspicious of how much you're distorting the data. And so it takes some time to explain what the weighting techniques are and why they ought to be used. And again, as I said several times already, the main disadvantage of the strata method, even though it's fairly easy to implement, is that it's very complex to present. You're presenting an analysis for each of the 5 quintiles, and of course that becomes very cumbersome, becomes very long and drawn out. And in our experience, presenting the strata analysis is too much. Non-technical audiences have a hard time understanding what you're talking about and really have a hard time understanding what are the key findings from your analysis. So again, our recommendation, kind of weighing all these data adjustments, the technical expertise needed, and how easy it is to present, or the ease of presentation of the results, our advice is when you're running these models is to use the covariate adjustment model and the case matching model. That's what we recommend in doing community corrections research, in that both are very easy to understand. The covariate adjustment doesn't really change the structure of the data, which helps in presentation. And the case matching method provides a more rigorous testing of treatment, and it's very simple to present, but it takes a lot of modeling experience. So we think those two, if you can master those 2 techniques, that should cover 90% of what you need to do to evaluate treatment.
There are several implications for research and practice from this research, and we drew many of the implications that we're going to talk about today from our interviews that we did with 24 parole officers throughout the state of Iowa. The implications that we're going to talk about today are for risk assessment, treatment assessment, and subpopulation differences. The LSI is a good predictor of treatment and recidivism, and that is a quantitative finding. The strongest effects that we found were for psychological risk and criminal history components of the LSI, and they were very good predictors of recidivism. However, the LSI has constrained variation among prisoners, and a lot of the variation in the LSI occurs between low threshold offenders and high threshold offenders, or you might think of it as being the distinction between probationers and parolees. So with the all prisoner sample, there is constrained variation, which means that it may not be as strong a predictor as it is in a general offender population. Moreover, it's a very stable measure, and if you can compare LSI scores across time in order to see that. We learned when we interviewed parole officers that this is one of the things that made it unattractive to them. If you think about a parole officer's job, they have to work every day with clients, and they become, as a result of that, very concerned with the daily life and current conditions of clients, psychological well-being, signs of psychological breakdown, signs of slipping into substance abuse. In fact, many parole officers said that they first assume when they take on a new client that's coming from the penitentiary that that client is high risk. They treat all clients at high risk as the beginning. So the LSI's stability and the fact that much of it is based on criminal history is an unattractive feature for them because, as many officers told us, your history can't be changed, but I care a great deal about what's happening to an offender right now. This is not necessarily an unfortunate thing. In fact, Iowa right now is implementing an additional and more fluid risk assessment called the DRARE. As we speak, they're testing it throughout the state and plan to implement it next year or very soon. Officers did like some elements of the LSI and are glad that the DRARE also has some stability indicators in it. And one of the features that they liked of the LSI is that it goes through all of the things that you want to know about a client anyway when they come on. In fact, many officers have been doing the job so long that they say thinking about the world in terms of the LSI or with the LS mind is almost comes natural to them, almost impossible not to do. And they say, who would not want to know the components of the LSI when they take on a new client? So we say that the officers told us that the LSI is a very valuable heuristic, and this too may be good news for this state because currently there are no plans to eliminate the LSI as a risk assessment instrument. It's still going to be used throughout the correctional system, and it will still be used when a client first comes on to parole. So perhaps this combination of a fluid and stable instrument is a valuable thing for other states to consider. When it comes to treatment assessment, there were a couple of implications that we learned as well. First of all, completion of a high priority program had strong effects on reducing recidivism, but we found no effect for quality scores. However, if you think about how the quality scores were collected and what the data looks like, quality scores were annual snapshots taken by evaluation teams who went and visited each program, evaluated them with a fairly complex criteria. But in the end, they created a raw score, which ranges only from 1 to 3, from not satisfactory to program is currently satisfactory, middle score being needs improvement. Most of the scores ranged between 2 and 3. The entire range possible is 1 and 3. So the scores, of course, not exhibiting much variation are not very good predictors of things. And I think that departments of corrections should probably consider better measures of programs with larger ranges and more items. Better measures should also perhaps contain engagement of offenders and certainly intensity of the program. Some officers, when we discussed treatment completion, were skeptical of closeout data, and that is a slight concern, but most of these thought that these were isolated problems of some officers not closing out or some officers changing scores to their advantage. But throughout the system, they thought that these sorts of data problems were small. However, officers in general overestimated high priority treatment completion. And we think the reason for that is that most of the persons who go through the penitentiary system do complete some sort of treatment. And officers were not sure how to distinguish high priority treatments from all the treatments that an inmate might receive. So one of the things that we heard repeatedly was, well, everyone has completed treatments and everyone has completed treatments for their needs. But given the short sentences that many offenders serve, a lot of the treatments that they had received are not very intense and very general sorts of things. And when our measure sorts into only completion of a high priority program, which probably has greater intensity. So one of the things, the implications from this is perhaps greater education efforts should be spent on educating community corrections personnel about the meaning of treatment completion and about the variation in intensity and requirements for completing various programs throughout the state. When it comes to subpopulation differences, one of the things that you might remember is we investigated but did not find community effects on recidivism, and that's in keeping with some previous research. However, we did find, if we divided the data between rural and urban offenders, large differences between the effectiveness of treatment. Treatment did not appear to be effective for rural offenders, but very effective for urban offenders. Now, given the distribution of offenders in most states and in the state of Iowa, most offenders are urban offenders. That's good news, that treatment appears to be having most of its effect in urban areas where most offenders are for urban offenders who are returning to urban areas, and that's where most offenders are concentrated. However, there is a population difference between rural and urban offenders, and we think that is a potential interaction between location and the effectiveness of treatment. To some degree, space, in this case, may be an indicator of population differences. Rural and urban offenders are different in the first place. So while community effects don't show up, maybe there's not a great deal of variation at the community level, and those things don't have real implications on offenders' lives and the way they behave, the effectiveness of treatment does seem to vary a great deal by place. There are differences in offenders may well be the reason. Recidivism, for example, is higher in urban areas. Risk levels with risk assessment instruments are higher in urban areas. Emotional and psychological problems are more common in rural areas. And violent and sex offenders are more common in rural areas. So these are potential places to look for the sources of this treatment effectiveness difference. At any rate, subpopulation differences are worth investigating. For one thing, in our study, We do not look at offenders who expired their sentence, and the reason is we were interested in community location. We couldn't determine with confidence where offenders resided who had expired their sentence, so this study is of offenders who are only on parole. Of course, it would be a great thing to know what those offenders who either choose to or do expire their sentence in the penitentiary, how they fare and what effect that treatment has for them. There are also differences between rural and urban contexts. There may well be differences by gender, race, and ethnicity. And because of the rural-urban difference that we found, we suggest that all of these subpopulation differences are worth exploring.